question that we left last time was something like this. We want to be able to account for this situation. We already have a table called toppings. And that contains the toppings ID, which is a primary key. It contains a toppings name, topping name, which is a unique index, and it contains calories. What we wanted to do is we wanted to do something like this. We wanted to define specialty pizzas that our place sells. And a specialty pizza comes with a certain predefined list of toppings. And you've probably seen these at pizza places. That maybe there's a Hawaiian pizza with ham and pineapple. Maybe there's meat lovers with pepperoni, sausage, bacon, and ham, and so on down the line. All right. The question we left off last time is we already have this table. All right, and that table we'll assume is correct, because it is correct. All right. The question is what other tables do we need to implement this piece of the problem within a relational database? Does anyone have a thought about that? What other table or tables do we need?
Just a specialty pizza table?
Just a specialty pizza table.
Yeah.
All right. So, and what's in this table?
A field for the name of the pizza.
Okay. So pizza name.
And then
What about pizza ID?
Okay. So especially pizza ID. Specialty pizza name. Okay. Anything else?
Ingredients?
Ingredients.
So you actually need a table for ingredients, maybe?
Okay. Tell you what, this is a good place to stop. All right, because this is part of the answer, but this isn't the whole answer. And I'm going to represent this as a drawing. In databases, we use what are called ERDs. That stands for Entity Relationship Diagrams. And these are usually easier to visualize than the name, than just looking at the words, looking at the names of the fields and so on. Because it's graphical. You know, the old picture is worth 1,000 words. All right? So right now we're saying we have these two entities. A specialty pizza entity whose fields contain the specialty pizza ID, and I can't write, and the specialty pizza name. Then we have another entity for toppings. We're going to assume that we don't need to keep track of, like, the things that are standard on every pizza, you know, the flour and the water and that kind of stuff. So as far as ingredients go, we're not interested in those ingredients. All right, we are interested in the toppings, though. So we have a toppings ID. Toppings name. And calories. One thing that you can tell just by looking at the ERD is there's no line between those two things. All right? What does a line on an ERD represent? It represents a connection, a relationship. All right? And a relationship is where a table points to another table. All right? And that we talked a little bit about that. That's known as a foreign key relationship. So, for example, if we had a class table and a teacher table, it might look like this. The class table might contain a class ID, which is a primary key, the class name, maybe the day and time that it meets, so on down the line. And then finally, it might contain a teacher ID, which is a foreign key in this table. When I say it's a foreign key in this table, I mean that it points to the primary key in another table. So in this case, there would be a teacher table that would contain a teacher ID, a teacher name, and any other attributes that we wanted for the teacher, their email address or office number, whatever. We would then draw this as a relationship between the two. Specifically then, we wouldn't just draw the line, we would draw something that indicated what's called the cardinality of the relationship. Cardinality means, what is the nature of the relationship? Is it a one-to-one relationship? You have three choices in databases: one-to-one, one-to-many, or many-to-many. And we'll boil down the fact that most relationships end up being one-to-many. All right, and we'll talk about that in a minute. All right. Now, this is, and to determine the cardinality, to determine if it's a one-to-one, one-to-many, many-to-many, you have to look in both directions. So one class has how many teachers? We'll assume one. All right. I mean, there might be some rare exceptions, but we'll not consider those. One teacher, though, teaches how many classes? Many. All right. So this is a one-to-many relationship. So that would be indicated sometimes by putting an M here and a 1 here. It can also be indicated by drawing what they call crow's feet in this direction. Thing to keep in mind in databases is there's only 3 numbers when you're talking about relationships in databases. There's 0, there's 1, and then there's many. So many is anything greater than 1. So you might say, well, a teacher teaches 4 classes, or a teacher teaches 5 classes, or something like that. It doesn't matter the exact number. If it's more than 1, it's considered to be many. All right? So you don't have to worry about the exact number of classes. That is from a database perspective. All right, if they teach more than 1, it's many. So that is a relationship between class and teacher. A class has 1 teacher. A teacher teaches multiple classes. So there'd be one-to-many relationship. How do you implement a one-to-many relationship? You implement the one-to-many relationship by having the ID of the one side as an attribute on the many side. So the class is a many. This is the 1. So you take the primary key of the 1 and you put it as an attribute in the many. In other words, if I was teacher number 1, 2, 3, I could be in this table 5 times. 1 for class 1, taught by teacher 1, 2, 3. 1 for class 2, taught by teacher 1, 2, 3. 1 for class 3, taught by teacher 1, 2, 3. All right? What you don't want to do is this. All right? Sometimes people get these reversed. All right? And they try something like this. wrong with this? What's wrong if I, instead of putting a teacher ID in the class table, I put a class ID in the teacher table? What's wrong with that?
Wouldn't it say that the teacher just has one class?
Exactly. I can only put one class ID in the teacher table. Therefore, I could only have one class for a teacher. This actually implements the opposite relationship. This would allow each teacher to have one class, but one class to have many teachers. So that's the exact opposite of what we want to do in this case. So you don't put, on the one side, you don't put the foreign key of the many side. You do the other way around. Another thing that people do sometimes is they think that, well, teachers only teach, well, maybe 5 classes. I don't know. I guess it depends what kind of school you're talking about, you know. Teachers only teach 5 classes or so, let's say. So I'm going to put class ID 1, class ID 2, class ID 3, class ID 4, and class ID 5. What's wrong with that picture? What's wrong with having multiple class IDs in the teacher table? That would allow you to put in 5 classes. So you could put in that the teacher teaches class 1, that the teacher teaches class 5, that the teacher teaches class 8, and so on. What's wrong with doing it that way? What's wrong with having multiple slots in the teacher table that we could put in all the classes that they teach?
The pain in the butt to adjust.
Right.
It is.
This is fixed, all right? This can't change. So what if something comes along and all of a sudden it's like, well, we got these mini courses we want these teachers to teach, and they only take half the time. So you can now teach 7 classes. Well, our database is set up to only allow 5.
It is.
All right? And therefore, that would break this database structure. Remember, there's no such thing as any number greater than 1 in a database other than many. So if it's more than 1, it's many. All right? So if we put a restriction on to say that a teacher can teach only 5, one of the fundamental things about software, as I've talked about before, is that the rules change at some point. All right, your organization changes its policy or its procedures, and maybe they are going to allow teachers to teach more than 5 classes and get paid overtime or whatever, all right? But something in the organization might change, and if you built that limitation in the database, that limitation is built into the structure of the whole application. Think of the database as being the foundation of the application, all right? If the foundation is strong, the building can be strong on top of it. If the foundation is weak, then the building is going to be weak as well. So therefore, you want to make the database as strong as possible. That's why we do things like putting the constraints in the database. We put the constraints in the database because then no one can violate those constraints. So if we create a foreign key, or we create a primary key, or we create saying that this field has to be a number or this field has to be a date, no one can violate it if that constraint is built into the database. Well, putting that in there is putting a limitation that is going to really affect the integrity of the data. You're either going to have to go back and change the database if that happens, or figure out some crazy workaround that won't be effective. Now, the good news is it's easy to design a correct solution to this that doesn't have the limitation. So it doesn't take that much more work to design a correct solution. The other thing is this makes all the queries more complicated. For example, if we had to look to see who teaches class 5, we have 5 slots in every teacher that we have to look at. All right. So it's just wrong all the way around. So don't do that. This, by the way, is one of the first rules of what's called normalization. Normalization is a procedure that you can apply to check to see if you've developed a well-designed database. There are 6 or so normalization rules. The first 3 are the most important. The 4th, 5th, and 6th are kind of like very unusual cases. So they're valid, but they don't come up real often. If you know the first 3 normalization rules well, you'll be good. And one of the first normalization rules is not to have any repeating fields. So don't have the same field multiple times in a table. In this case, we have a class ID stored 5 times. That's a repeating field. So nope, that violates the first normalization rule. The other part of the normalization rule is that every table should have a primary key, and we've taken care of that. So this is the wrong solution. Don't do this.
Right.
This is the right solution. Have a foreign key in the class that points to the teacher. Now, what is the relationship between specialty pizzas and toppings? Each specialty pizza can have how many toppings? Many.
Many.
Right?
As many as it wants.
I'm glad he didn't say 3 or 5 or whatever, because the exact number doesn't matter. It only matters if it's 0, right? If it's 0, then there's no relationship between them. If it's 1, then it's a certain kind of relationship. If it's many, then it's a certain kind of relationship. Each topping can be on how many specialty pizzas? Many? Does that sound good? Another way to say this is how many specialty pizzas could have pepperoni on it? Many, right? How many specialty pizzas could have ham on it? Many. All right? So therefore, this is a many-to-many relationship. This is different than the one-to-many relationship. All right? The one-to-many relationship we showed you over there. All right? The many-to-many relationship is a little different. You cannot implement directly a many-to-many relationship in a relational database between 2 tables. You have to introduce a third table. All right? Let's think about it for a second. Let's say I put specialty ID in the toppings table. All right? That would allow the specialty pizza to have multiple toppings, right? Because I could put specialty ID 1 on pineapple, specialty ID 1 on ham, and so on down the line. So each specialty pizza could have more than 1 topping if I put the specialty pizza ID in the topping table. But guess what? Each topping could only be on 1 specialty pizza. So that would make that a one-to-many relationship in our database.
Yes.
So if I did this, if I put specialty pizza ID here, then each pizza could have multiple toppings, but each topping could only point to 1 specialty pizza. So it wouldn't be a many-to-many relationship, it would be a one-to-many relationship. Same thing works the other direction. If I were to put a toppings ID here, then each topping could be on multiple specialty pizzas, right? Pepperoni could be on specialty pizza 1 and specialty pizza 5 and specialty pizza 10 and so on. But each specialty pizza would only have what? 1 topping associated with it. So that's also incorrect. So what do? I have to introduce a third table. And that third table is typically called an intersecting entity. All right? And typically what it consists of is you can do this several different ways. We'll talk about one way, and we'll probably talk about the other way too. All right? But one way you can do it is make the primary key of both tables the primary key in this table. So this could have a primary key of toppings ID and specialty pizza ID. And then we'll have a foreign key over to the related table. Now let's look at what this accomplishes. Let's put up some specialty pizzas and some toppings and make sure we've achieved our goal. So let's say we have specialty pizza 1, which is the Hawaiian pizza. Specialty pizza 2, which is the meat lovers. Specialty pizza 3, which is the supreme. All right. So that's 3 specialty pizzas that we have. Let's say we have some toppings. Topping 1 is pepperoni. Topping 2 is pineapple. Topping 3 is ham.
Right.
Topping 4 is sausage.
Yes.
Topping 5 is green peppers. And that should be enough for us to do what we need to do with this.
Yeah, it should be enough.
So let's say Hawaiian has pineapple and ham. Let's say Meat Lovers has pepperoni, ham, and sausage. And let's say Supreme has pepperoni, sausage, and green pepper. So, what would our toppings pizza table look like? Usually, by the way, we call the intersecting table or intersecting entity by the combination of the 2 other tables. So, toppings pizza or toppings specialty pizza would be like a good name for this table. And one way to do this would be to make its primary key the toppings ID plus the specialty pizza ID. So what would this table look like, the toppings pizza? Topping ID, pizza ID. So, the Hawaiian pizza has pineapple and ham. So for pizza ID 1, we have pineapple. That'd be topping ID 2. For pizza ID 1, we also have ham, which is 3. So there'd be 2 entries in the toppings table for the Hawaiian pizza. The Meat Lovers pizza, which is number 2, is pepperoni, which is 1,
Yep.
ham, which is 3,
Yep.
and sausage, which is 4.
Right.
Finally, the Supreme, which is pepperoni, sausage, and green pepper, would have pepperoni, sausage, and green pepper. All right? Now, a couple things to notice. First of all, if we make both these a primary key, this combination has to be unique. So I could not put in twice that a Supreme pizza has pepperoni on it. If I tried to put in that topping 1 is on a Supreme, if it's already in there, it won't let me put it in there again. But that's okay, right? It's just that it's enough to say that that topping's on the pizza. We don't need to store it in there more than once. This allows us flexibility to have as many toppings as we want. So, for example, if we were to decide to create a new topping, all of a sudden we have bacon, and bacon goes on a Meat Lovers pizza, all we would have to do is insert a row in this table that says, on the Meat Lovers pizza, there is bacon. And there's no limit to how many toppings that we could have. So, relationships, cardinality. All right? you are designing a database, you draw the entities as squares or rectangles. You then look to see where there's a relationship between the entities, and you draw lines between them. You also look for the cardinality of the relationships. That is it one-to-one, one-to-many, or many-to-many? A one-to-many relationship, the many side points to the one. So whatever the one side has the primary key of, you put that as a foreign key in the many side. A many-to-many relationship, you create an intersecting table. And usually the key is a combination of the two keys from the two separate tables. You could create it as having its own surrogate key and having the other two as attributes. That would be especially possible if something could be, if there was a many-to-many but it wasn't unique. For example, I could place an order for 2 of a certain product, right? So I might have that item on my order 2 times. Then I would have a separate key for that intersecting table and those other 2 as foreign keys. One-to-one relationships are pretty rare. It's even hard to think of an example of one. The one example I can think of would be like the relationship between department in a college and the dean. All right? Each department only has one dean. All right? There's no co-deaning or tag team deaning or anything like that. So there's only one dean per department. And each dean is only the dean of one department. So if you're the dean of engineering, business and information technology, you're not also going to be the dean of math and sciences. So that would be an example of a one-to-one relationship between dean and department. Manager and baseball team. That'd be another example of a one-to-one relationship. So there are one-to-one relationships in databases, but generally they're pretty rare. All right? Typically, you're going to end up with one-to-many relationships or many-to-many relationships. And as a spoiler alert, one-to-many or many-to-many relationships get turned into one-to-many relationships. So you're going to have a lot of one-to-many relationships in your database.
True.
Any questions about this? The rest of the normalization rules relate to storing data in only one place. Let me show you what I mean. We'll use this example. And I forget the numbers of the rules. I guess the numbers of the rules are important if it's going to be on the test or something, but it's more important to know the content of the normalization rules than to know the number. First rule, again, no repeating fields. That gets back to the whole thing of databases not having any numbers except 0, 1, and many. Second one relates to data should only depend on the entire key. So if I stored in this table the name of the ingredient.
Yep.
I won't do the rest. What's wrong with storing the name of the ingredient in there, in this table? Well, number one is it takes up more space. All right, so that's bad. It takes up more space and it doesn't add any value. It doesn't add any value. Why? Well, if we want the name of the topping, we can always go to this table and look it up. So having it there doesn't really give us anything. It takes up more space, and we can already get the name if we wanted it, simply by looking in this table. So that's one thing that's bad about it. That, by the way, is called redundant. All right? It's duplicated, and it doesn't add any value. All right? Just because something is duplicated doesn't necessarily mean it's redundant. But when it's duplicated and it doesn't add any value, then, well, that's a redundancy. What's bad about being redundant? I'll give you an example. Let's say I called and ordered a meat lover's pizza, and I expected there to be kielbasa on the pizza, Polish sausage on the pizza. So I expected pepperoni, Polish sausage, and ham on the pizza. And to my door was delivered a pizza with Italian sausage, pepperoni, and ham.
Oh boy.
Oh,
How dare they?
how dare they? Exactly. So I complain. I write an angry letter. And I say, there is only one true sausage, and that is kielbasa. And how dare you call that other kind of, whatever it was, sausage. All right? Being proud of my Polish heritage. All right? So, the manager looks and says, yeah, they're right. We should be more specific. We should call it Italian sausage. That will remove this problem in the future. Right? Now, where do they have to change the name if it's stored here and if it's stored here? They have to change it in two places. So, okay, I go and change Italian sausage, but what if I forget to change one of these? All right?
Yeah.
Or I forget to change any of them. Then I'm going to have an inconsistency. It's going to be called sausage in one place and Italian sausage in another place. It's not good. All right? You can remove that problem altogether simply by only storing everything in one place. And that, in a nutshell, is what a lot of the normalization rules are about. We're going to store the data only in one place, so we don't have to worry about it being inconsistent. Yeah, we need to change it from sausage to Italian sausage, all right, or whatever, but we don't have to worry about forgetting to change it somewhere else. That's one example of, I think, Normalization Rule 2, which formally states that the fields need to depend on the whole key, not just part of the key. So in this case, the sausage, the name of the ingredient, the name of the topping, only depends on the topping part. It doesn't depend on the pizza. We don't call sausage something different depending on what pizza it's on. It's sausage, or more correctly, Italian sausage. Now the last normalization rule would be, or the third normalization rule, would be that don't have something that only depends on part of the key. So let's go back to this teacher example for just a second. We have the class ID, the class name, the teacher ID. So the many side points to the one side. We have our teacher table that has a teacher ID, teacher name, and so on. We would not store the teacher name in this table. Why not? Exact same thing. The teacher name doesn't depend on the class ID. I don't have different identities for different classes I teach. That would be really cool if I did. Like if you showed up for my Java class, I'd be like Mr. Smith or something. I'd come in, look the same, and all that, talk the same. But no, I'm Mr. Smith because it's Java. No. The name only depends on who the teacher is. So I'm Zellers in all my classes.
Okay.
All right. So therefore, why would you store the name associated with the class? What would happen? Well, let's say I did change my name. If I decided Zellers is too long and hard to spell or something, so I changed it to Zell, all right, then you'd have to go and change it in all the places. Again, if you don't store duplicated, redundant data, you don't have to worry about changing it everywhere. You change the data in one place. Fundamental rule of a database, that each piece of data is only stored in one place. All right? That way you only need to change it in one place. And the interesting thing is, if you think about it, that's very similar to what we do with our code, right? Our goal with our code is to have stuff only in one place. Why? So when we have to change it, we don't have to change it in 15 places. We can just change it into one. So we have master pages. So we have CSS pages. So we have our custom classes. All the things that we do is for that goal of making it easy to change. Why? Because change is just the reality of the software development world. All right? Even if you do things perfectly, the business can change. All right? Rules can change. Laws can change. And therefore, you have to be able to accommodate those changes as easily as possible. Now, some people look at this and say, well, isn't this redundant data? Because that's duplicating the topping ID and the piece ID. Not really. This is providing new information. This is providing a relationship between those two tables. So that's different than simply having a list of the IDs and toppings and a list of IDs and specialty pieces. All right? So this is not an example of redundancy. All right, now let's check the time. Okay. I have two different times on these. I will perform a mathematical operation and try to figure out the correct time. I'm guessing it's about 5 to 11. Is that right?
It's 10:55.
It's 7:55,
Okay.
yeah.
Okay. Oh, I was mistaken then. It's not 5 to 11. All right. What I'm going to do is this. I'm going to implement this in the database, and then I want to write some queries that will show this. I want to write these queries because these queries will be different than the first query we wrote in that it will involve multiple tables. I also want to get what can be described as parameterized queries. Parameterized queries are when you don't get everything in the table, but you ask for something, and you get that back. You know, you get just what you asked for. You don't get everything. So let's go in and create these tables in our database, and I'll put some data in, and we'll go from there. You would think, after using a keyboard for over 40 years, I would be better at it. You'd be wrong. All right, so let's download what we had last time.
Tractor's not on.
Oh. There we go. Good. So let's download what we had before. By the way, scary thought. We're like midway through the semester, more or less.
I agree.
Open up Visual Studio, open up by application. So I'm going to go in the database, and I'm going to add those tables. So the first thing I'm going to do is create table. We're going to go into Design View, and we'll create the Specialty Pizza table. Primary key will make Specialty Pizza ID,
Yeah.
which is an auto number field. Again, it doesn't really matter what we call those things, right? I mean, how we number them. Hawaiian could be 1.
Could be.
You know, it doesn't matter. We'll have the Specialty Pizza name. Which will make a text. And I'm going to make it a unique index. I'm going to make it required. And I'm going to make it index. I'm going to make it unique. Because I shouldn't be able to have 2 Hawaiian pizzas. You know. Oh, I ordered a Hawaiian pizza. I got something else. Well, you ordered the other Hawaiian pizza. Well, that doesn't make sense, right? You should guarantee that that should be unique. Do we have other attributes in here? I don't think so. I think that was it. All right. So let's go and enter a few things into this table. So I'm going to enter in Hawaiian, meat lovers, supreme. Oh, I wish I had. Forget the name of the place. There's one in Lakewood. There's one in Cleveland Heights that has a lot of specialty pizzas that are really good.
Angelo's?
I don't know. Any pizza place named Angelo's is a good place, right? So that there used to be an Angelo's in Amherst that was pretty good, but I don't remember it. Oh crap! I can picture the place coming in because you can see the guys working on the pizzas as you walk in. Pardon me?
Mellow mushroom?
Oh, I got a story about mellow mushroom, but we won't tell that one now. Oh, I don't remember. Shoot, this burned me up. Anyhow, okay, so you see, I should pick boring topics and not exciting topics like pizza. I'll be less likely to get sidetracked. All right, so one is a Hawaiian pizza. All right, I'm going to go and I'm going to enter my other table, which is the intersecting table, and I'm going to call it topping. I'll call it specialty pizza topping. So the name usually suggests that this is the intersecting table between those two tables. All right. So it's a good sort of convention to follow. And it's going to have a specialty pizza ID. And it's going to have a topping ID. Now, in this table, specialty pizza ID is not an auto number. It matches to an auto number. But it's not like the first thing I add in this gets a topping ID or a specialty pizza ID of 1. I have to manually pick the thing that I want. All right? And likewise, this is going to be number. Now, one thing sometimes students get a little confused about is when I'm going to enter data into this table, I have to know the ID numbers for these specialty pizzas, and I have to know the ID numbers for the toppings. All right? That's okay. We're sort of getting data in directly into the database. If we were developing this as an application for our pizza place, we would give a user interface by which they could easily enter these values in. Maybe a drag and drop interface where you define a specialty pizza and drag over the toppings that you want into it. But we could develop something that was very user-friendly. So the person wouldn't have to remember the numbers to do this. This is just because we're sort of jumping into this and we just want to get some data in quickly. So we're going to do it that way. Now, this has a two-part primary key. How do you make a two-part primary key? You highlight the two fields. You kind of just click and drag between them, and you click primary key. That will make both parts of them the primary key. That means that both fields must be entered. I can't have a null for one of them. And the combination of the two has to be unique. All right? Now, I'm going to do one more thing, because I don't have a foreign key relationship yet. I just happen to have fields with the same name. That does not make for a foreign key. I have to define these as a foreign key. And the way that you do that in Access is going into relationships. So I'll go to Create. I'll click around here confused for a few minutes. Then I'll find on Database Tools as relationships. I'm going to pick all three of these tables. And then I'm going to drag the matching fields together. So I'm going to drag from specialty pizza to specialty pizza ID. And I have a choice. If I'm developing a brand new database, I will always check enforce referential integrity. Because that's what truly makes it a foreign key. If you leave this unchecked, you don't really get the advantages of a foreign key, and your database could have bad data. The only time I would leave this unchecked is if I was bringing data from, let's say, an Excel worksheet into Access or into a relational database. And because Excel's Excel, I might have some bogus data in there. And I'd take some time to clean up the data and make sure that everything matched up with everything else. So I might import it into a database without referential integrity enforced. Initially, I could clean up my data, and then I would go back and check this to enforce referential integrity. But before I went live, I would want to make sure that enforced referential integrity was implemented. All right? Now, you have options to Cascade. Cascade update we're not really going to talk about because if you're using auto number keys, it's really not that relevant. Cascade Delete is relevant though. And what that says is when you delete the parent, what should you do? Should you delete all the children? Or should you keep, yeah, I know that sounds horrible. Or should you prevent the user from being able to delete the parent? That's your choices. It's either Cascade or Restrict. In this case, if I got rid of the Hawaiian pizza, if that was not a good seller, so I said, well, I'm no longer going to do the Hawaiian pizza. Would I want to delete all the toppings that are associated with it? Not the toppings themselves, but in the intersecting table. Yeah, that would be pretty safe assumption. If I'm going to get rid of the Hawaiian pizza, I don't need to know what goes on a Hawaiian pizza anymore. All right? So I'm going to Cascade Delete for this. Notice it shows one to many this way. One of these is associated with many of these. Use that as a check of your own database design. If those things are like pointing in the opposite direction, you probably did something wrong. Toppings, I'm going to do the same thing too. I'm going to enforce referential integrity. And I'm not going to cascade for this one. Why? Well, let's say I want to delete ham. All right? Just because I delete ham doesn't mean I want to go through and delete the meat lover's pizza and the Hawaiian pizza and so on. All right?
Cool.
So therefore, I will only allow you to delete a topping if it's not on any of my specialty pizzas. And if it's on one of my specialty pizzas, then I won't let you delete it. You'll have to go in and change it, maybe put in a substitute topping or something like that. All right? So I'm going to restrict deletion for these. All right, and I have my many-to-many established. Remember, you have to implement relationships to get the benefits of the foreign key. Now, the other thing, all right? What is the other thing? Give me a second. It'll come to me. Oh. Why would I want to do this before I've started entering data? Why would I want to create the relationships before I've started entering data? Yes?
So that you can't enter data incorrectly, like you don't spend a lot of time making
Right.
something that isn't going to work.
Right. So that I didn't go in and enter something that was invalid, like Specialty Pizza 87 has topping 673 when I don't have those in my database, right? If I don't have the foreign keys established, then I can enter anything in there, and it might not even make sense. So I would put these constraints on because I want to constrain. I want to make sure that I only enter invalid data, all right? So therefore, I'm going to put the constraints in before I start entering data. Again, the only exception would be is if you're converting data. Now, I've done a lot of projects in the past with that, where someone has a Excel system that's sort of successful, but it lacks the validity of a database, so they want to convert it to a relational database. So you bring the data into a database, but because Excel is flawed, it's not the right tool for a relational database. You have to go in and clean up the data, and then you'd apply it. But those are the exceptions. So let's go and enter in a couple of specialty pieces here. We have Hawaiian as number 1. I think I spelled Hawaiian wrong. I think. I don't know. And a Hawaiian, let's say, contains pineapple and ham. All right. So it contains toppings 2 and 7. Specialty Pizza 1 contains toppings 2 and 7. So I'll go into Specialty Pizza and say 1 contains 2, 1 contains 7. If I go in and try to enter something ridiculous in, that 1 contains topping 234, I get an error because it's telling me there's no such thing as toppings 234. And that's good. That is the referential integrity. It's making sure that I can enter something in that doesn't match up with an invalid topping. Because if I were able to do so, then my data would not be valid. If my data is not valid, then the information I get from that data is not going to be valid. So I'll click OK, and I'll sometimes Access is weird like that. I'm going to put in 3, and I'm going to go back and delete it. So, I have in there that Specialty Pizza 1, which is Hawaiian, has 2 and 7. All right? Let's enter another Specialty Pizza in. Let's enter the Meat Lovers, which contains pepperoni and ham. Okay, so 1 and 7. So Specialty Pizza 2 contains 1 and 7. And likewise, I couldn't put in an invalid specialty pizza or an invalid topping pizza. I also could not put in the same thing twice. So I couldn't say, yeah, it has ham again. Because again, that's a duplicate field, because that combination is not unique. So again, I have to sort of trick access by entering a bogus value and then deleting it. All right. So now we're ready to go to the ASP.NET side. And here's what I want to do. I want to create a page that has a drop-down that shows all my specialty pieces. In this case, there's only 2. All right? But in the interest of time, we'll leave it at 2. I want a page that shows a drop-down that shows all my specialty pieces. I want to pick one of those pizzas, and then I want to show the toppings that are on that pizza. So the drop-down will show up. I will get Hawaiian and meat lovers will show up. All right? I will pick one of those 2 and click Submit. And then down below it will show the list of ingredients or list of toppings for that pizza. All right? So this is an extension from what we've done before. We're doing 2 new things. All right? We're doing 2 new things. We are doing a drop-down that is populated from the database. Remember, in our first examples, when we created drop-downs, we hard-coded the numbers in. We went and hard-coded the choices in. So for rock, paper, and scissors, you went hard. If you used a drop-down, you went hard-coded that 0 was rock, 1 was paper, and 3 was scissors, or 2 was scissors. Here we're going to populate the drop-down from the database. So that's one thing that we're going to do. Second thing that we're going to do is our query is going to be parameterized. In other words, what we're showing in the grid is going to depend on what we've selected in the drop-down. So we're not going to show everything in that grid. We are just going to show the things that meet the criteria that we've entered in. All right, so we're only going to show the toppings that are associated with that specialty pizza. There's a third thing that's different than this, and that is our select statement will involve more than one table. All right? So let's do this one sort of step at a time. Let's first make the drop down.
Okay, right.
Now, if we think about this, one thing that I suggest doing always is performing sort of a mental inventory, like I just did there, of what it has to do, what we have to do, what we have done in the past that is like it, and what is different. So we pulled data from a database. Yeah, we've done that. We haven't pulled data from a database and put it in a drop-down. But we probably have a good idea how to do that, right? Because we know there's something called data binding, and we probably are going to do something like that. We have not used criteria to pull up data in a query, so that'll be a new thing. We haven't done more than one table, and that's a new thing. The other thing that's useful is to think about what objects you're going to have. How many data sources are we going to have on this page? The answer is probably either 1 or 2. All right? We're going to have a drop-down that shows a list of specialty pizzas, and then we're going to have a grid view that shows the list of toppings for the selected pizza. So how many data sources are we going to have? 1 or 2? 50-50 chance. The room is dark, so if you change your voice, I won't know who it is. 2. All right. Good answer.
Man, I know that was you.
Well, in that case, it's good. You got the answer right? Why did you say 2? Or is it just a guess?
Because we have to pull information from the specialty pizzas to have the name of the pizza, and then from toppings, now the toppings are on the pizza.
Yeah. A good way to do it is to describe in words what you need to pull from the database. And if there's different descriptions for the things that you're going to pull, then it's probably a different data source. In one case, I'm going to pull the list of specialty pizzas to populate the drop-down. In the other case, I'm going to pull a list of toppings for one of the specialty pizzas. Well, that's a totally different description, right? Therefore, it's going to end up being different data sources. So let's go into Visual Studio and create this. And we should be able to get through this. So I'm going to go and file, new, file, web form. We'll call it specialty. Add. I'm going to right mouse and say I want this guy to be my start page so that we'll test it. I'm going to go into design view. Do keep in mind as I'm designing these, I'm not spending effort to make them look pretty. All right, that's sort of your job on your assignments to go and do that. I'm just showing the functionality. So, I'm going to do this a bit at a time. First thing I'm going to do is this happens occasionally, and I don't know why. I'm going to close it and restart. What's happening is I can't see any of the tools that I want to bring over. So I'm going to start this up again. Alright, and there they are. Okay, so I'm going to start out, I'm going to do the drop-down piece of it right. The drop-down is going to show the list of specialty pizzas. So I'm going to go to standard. I'm going to drag over drop-down list. Alright. I'm going to say choose data source, and I don't want to do that. I have to define a data source. So I will go and say define a SQL data source. Configure it. Connection, I'm not going to do connection, right? If you remember, we did this the first time we created a connection. We want all of the connections to this specific database to use the same database connection. We don't want multiple connections. Why is that? Again, you should just be able to shout out maintainability whenever I ask why you do something. Because that's why you do almost everything. We only want one connection in the web config file because if we have to change it, we only want to change it in one place. So I'm going to pick my connection, pizza connection string. Next, what do I want to see? I want to see the specialty pizza ID and specialty pizza name. Remember, the ID is what the system needs to do its job, right? Because that's the foreign key into the specialty pizza's toppings table. So I need that ID to pull up data from that table. All right, but the user's not going to understand what topping or what specialty pizza 1, 2, and 3 means. So therefore, we want the name as well. I'm going to order it. I'm going to put it in alphabetical order, and what happened? Oh, I forgot to click test query. I just clicked finish. Test query, well, there it shows. All right. That's what we want. And I'll click Finish. That is only one part of it. That's the data part. Remember, whenever you have the, whenever we were pulling data from a database, there's the two pieces. There's the data itself, the data source, then there's the visual component. And the visual component, in our case, is a drop-down. Now we have to bind those two together. We have to say that the data for this guy comes from this data source. So that's what I do here. Choose data source. SQL data source 1. What is the field we want to display in the drop-down? Well, that's what the users are going to see, so we want to display the specialty name. What is the data field for the value of the drop-down going to be? That's going to be the PISA ID. Remember, the display field is what the users need to see. The value is going to be what the script needs to see. Remember, with every drop-down option, you have the part that the user sees, and you have the value that is sort of exists behind the scenes. Well, we need the value to do the database queries. So remember when I said a while ago, I talked about creating a data source that I almost always pick the key. You typically need the key always. In this case, we don't need it to display the name of the pizza. We need it to get the ID so that we can pull that up. So now, if we run this, we'll get a drop down. That contains clearly this sheet is a Cleveland Indians fan and is having a tough morning today.
Oh, Lord.
Too soon?
That was rough.
Obviously.
All right, here we go. Not responding.
Oh, great.
Oh, and there we go.
Oh, now we're getting somewhere, aren't we?
There is my drop down. I'll make the display bigger. That shows the specialty pizza.
I think it's supposed to be zoomed in.
Yeah, it might be. There we go. And the drop down. So it does have a drop down. If we view the source for this, which should probably take the next half hour or so, we will see that in the source is the value will be the primary key. The value of each of these options will be the primary key of the specialty pizza. Well, you'll take my word for that. All right, let's go and do the second piece of this. Now again, we already said we want a different data source because we just described it as different data. And we're back to that nonsense again.
Yes, well.
All right, I'm going to call it a day because we're almost at the end of class anyhow,
Yeah, we are.
and obviously this is not responding well.
No.
Here's your challenge for next Monday. See if you can figure out how to make it so that if we change the value in the drop-down, it shows me the ingredients, or it shows me the toppings for that pizza. We haven't done everything we needed to. We've done part of it, but with a little bit of work, you might be able to figure out what you need to do. All right, I will go and unlock lab. I'll come back to get these files, and we'll pick up on this on Tuesday.
Tuesday, yeah. Yeah, this.